Question 4 here gives us an equation and then gives us an interval and wants us to determine the absolute minimum and absolute maximum on the interval that they've given us. So the first thing we want to do is quickly talk about what an absolute max and what an absolute min mean. And so whenever I'm talking about an absolute max, I'm looking for the largest y value in the window. We'll talk about what that in the window piece means here in a second. So absolute min, whenever I'm looking for an absolute min, well, in that situation, I'm looking for the smallest y value in the window. And so when I say in the window, on any absolute max min problem, you're going to be given an interval to work with. And this -4 to 1, that is your x window that you're going to want to make sure you lock in when you're graphing this equation. Because we don't care about maxes and mins that happen outside of that window. We only care what's happening inside of that window. The other thing to know about absolute min problems is you're always going to have both. So if there's ever an answer that says you don't have a max or you don't have a min, you can go ahead and throw that one out. Like E here, we know for a fact we're going to have a max or a min, so it's definitely not going to be E where there's no max or no min. So when I talk through this, just to give you a visualization of what I mean by largest and smallest y values, we no longer care if these things are happening at peaks and valleys. If my graph starts on the left-hand side here and just goes straight across to the right-hand side, this right-hand endpoint is where my absolute max is happening because it's the largest y value. And this left endpoint is where my absolute min is happening because it's the smallest y value. I don't even care if there's a whole bunch of peaks and valleys happening. All I'm concerned with when I look at this graph is where is the tallest point, which would still be the right endpoint in this situation, and where is the smallest endpoint, or smallest y value, which would be the left endpoint. You can have peaks and valleys come through, but you don't always have to have them. I could have a graph that starts here and goes up and then comes back down. And in this situation, I would definitely have an absolute max happening up at the top here, but my absolute min would still be happening at that left endpoint. And so whenever you're looking at an absolute max min problem, you just have to determine where the max, the largest y value, and where the smallest y value are occurring. If they're occurring at a peak, then this would be a calc max situation. If it's happening at a valley, then we'd be looking at a calc min situation. So if we're looking at something like this or something like that, but if it's happening at one of our endpoints, which is very possible, then this would be a calc value setup because we know where the min or the max is happening. It's happening at one of those endpoints. And so we're just going to plug that point into our equation to get out what the y value is that goes with them. So to do a problem like this, what I would do is I would come and I would take the equation they give me, and I'm going to put that into y1 on my calculator. So x squared plus 2x plus 4. So we'll do that. And then from there, we're just going to graph it and see which of our three situations we're in and how to find our maxes and mins based upon those situations. So opening up my calculator, and I type into there y equals x squared plus 2x plus 4. I go ahead and go in and set my window. I'm going to make it to go from -4 to 1 on my x min and my x max. And then I went ahead and bumped my y max up to 20 so that I could see the full graph. So when I graph this, you'll notice that I have an absolute max happening at the left endpoint here, and I've got an absolute min happening at a valley in the middle right there. So to calc a max, whenever, either if it was a max or a min, but if I'm calculating something at an endpoint, that's when I'm going to do a second calc, and then I'm going to choose number 1 value in that situation. I know where that left endpoint is. I set my window to have -4 as that left endpoint over here. So I'm typing in -4 to get out that y value. And that tells me that at -4 I have a y value equal to 12. So my absolute max is going to be at the point -4, 12. And so now I come in to find my absolute min. And we saw that that was happening at a valley for us. And so in this situation, when it's happening at a valley, we would do a second calc, and we would choose number 3 minimum. It's going to ask us 3 questions. The first thing it's going to say is find a point to the left of the minimum. So scroll anywhere to the left of the minimum and hit enter. And then it's going to want a right bound, a right some point to the right of where you think the minimum is. So just scroll so you're for sure to the right of where the minimum is and hit enter. And then guess, we don't care, go ahead and hit enter. And what you can see is we're getting an x value equal to -1 and a y value equal to 3. So our absolute minimum is happening at -1, 3. So whenever you're talking about maxes and mins, the y value is that max or min. So the absolute max is 12. The absolute minimum is 3. So we're looking for an absolute maximum of 12 and an absolute minimum of 3. So our answer would be C.